Problem 4. In the diagram below of triangle RST, they tell me the measure of angle T is 90 degrees. That's them just telling me, hey, it's a right triangle. And then they tell me, you know, you got a side that's 65, great, and another side that's 60. Awesome. Here is the question. They want to know what's the measure of an angle, S, which we'll call X, to the nearest degree. That's a whole number. So once again, this is inverse trig. See problem 3 if you want to know more about inverse trig and why we're using it. Basically, inverse trig allows us to find angles, and that's why we're using it. We're going to start by labeling the hypotenuse, right? That's opposite the 90-degree angle. Then we're going to find what's the opposite of our reference angle, which we're not using in this problem, and the adjacent. So here we're using the adjacent and hypotenuse, and added a whole entire sol, ka, and tela. Adjacent and hypotenuse is a cosine type thing, so this is the inverse cosine, since we're looking for an angle, of the adjacent divided by the hypotenuse. And all we gotta do is type that in our handy dandy calculator. Inverse cosine, right, second and the trig function. 60, our adjacent, divided by 65, our hypotenuse. We can see it's 22.619. And they wanted us to round this to the nearest degree. So we gotta figure out, do we keep that as 22 or do we round it up to 23? And we're gonna look to the right. And since that's 5 or higher, we round it up. So we can say the measure of angle S equals 23